Hello, good morning everyone. How are you? Okay, today is the sixth meeting and today's lecture topic is modeling relationship between two variables. Topic 6 week and 7 week are interrelated, and today lectures we are talking about association and correlations, and then covering the relationship between two categorical variables, the relationship between one categorical variable and one numeric variable, and relationship between two numerical variables. And then next week at the lecture 7, we are talking about linear regression analysis. We are talking about simple linear regression, and then covering about model formulation, parameter estimation, and graphic and model interpretation. Now, let's start to discuss about association and correlation. First, I want to explain about bivariate data before we start with correlation and associations topic. Variable is any characteristic of the object in the population or sample to be analyzed. And as we discussed in earlier lectures, data is a value, can be either categorical or quantitative, that is measured for a variable. I hope that you still remember what we have discussed earlier many times. If we have only one variable being measured, then we call it univariate data. And if two variables are measured, then we call it bivariate data. Okay? Three combinations of bivariate data. The first one is the two variables are categorical. The second one is one categorical variable and one numeric variable. The third is both variables are numeric. So that easier for you to understand, I want to give you example for each case. The first case is both variables are categorical. For example, like this. You make a survey, and then the survey was conducted to investigate the relationship between respondents' preference for information through various information media. In this case is television, radio, and newspaper. And the second variable is gender. Okay, let's remember the first variable is media. There are three categories: television, radio, and newspaper. And then the second variable is gender, of course male and female. The question in this example is there a relationship between the information media used and gender or not? Second example is one categorical variable and one numeric variable. For example, we have 10 random samples of households from each of the 6 different sub-districts in Bogor are taken, and their electricity bill are recorded in June 2021. Sub-district here in Indonesia is kecamatan, and then electricity bills meaning here is biaya untuk listrik, tagihan listrik, right? Okay, I hope you understand what I mean. Sub-district or location in this case is a categorical variable with 6 categories. Let's say West Java, West Bogor, East Bogor, Central Bogor, North Bogor, South Bogor, and Tanah Sareal. This is the name of sub-district in Bogor, right? The amount of each household electricity bills is a numerical variables. Okay, I hope you understand about this variable. Okay, the question is, is there a relationship between the locations of residence and the amount of the electricity bills? The third example is both variables are numeric. I think this is the simplest example compared with example 1 and example 2. In a study, wanted to see the relationship between weight and height of children aged 10 to 12 years. Okay? I think you understand that both variables are numeric. Weight and height are both numerical variables. So that the question is there a relationship between weight and height? Okay, now we are talking about one by one case. The first case is the relationship between two categorical variables. So, to see the relationship between two categorical variables, we can use two possibilities. The first one is two-way frequency tables, or also called cross tables, or also called a cross classification. Okay, I think we a little bit discussed about this in earlier lectures. The second one, a measure of the closeness of relationship between categorical variable, often referred to as a measure of association, when measure of association is chi-square. Okay, let's remember with contingency table. Contingency table is a table that presents the number of observations for each combination of value for two categorical variables. Okay, do you still remember? Yeah. Okay. If, for example, if there are R categories for the first variable as a row and C categories for the second variable as a column, then this table is referred to as a cross tabulation R cross C or contingency table R cross C. Okay, look at the small picture in the bottom. Okay, let's look the table. I think it will easier to understand about what contingency table. R cross C, look at the category of the variable A, 1, 2 until R, and then as a column is category of variable B, and then there are 1, 2 until C column, and then in the cell in between combination of row and column, you know, O11, meaning is observation, frequency of observation, row 1 and column 1. O12 is the frequency of the row 1 and column 2, and until O1C. And then in the column 1 you will have O21, meaning is observations row 2 and column 1 until OR1. That means observation on the number of observation or frequency of observation, the row R and column 1. So in the last cell is ORC, meaning as the frequency of row R and column C. So look at the total of the column in the right side. This is the total, meaning that the O11 plus O12 until O1C, and then we give a symbol R1, that means row 1, the total for row 1, and then following the total of R2 until RR. In the other side, in the column 1, for example, if you sum the O11 plus O21 until OR1, and then you will have C1, then followed by C2 until CC. the total of row and total of column, and then it will be same, and then we give the symbol n, small n, meaning that this is the total of observations. Okay, back to the example 1. Two variables, information media versus gender. For example, the result of a survey of 1,320 respondents, the distribution of respondents according to the type of information media access and gender is as follows. Look at the table, yeah? It is clear. As a column is television, radio, newspaper. As a row is male and female. You can look at here the number of frequency, every cell, every combination between row and column, and then you can also look at the total of the row and total of the column. So meaning that, for example, the respondent with the male gender is 760, while female is 560. And then the total number of the respondent who watch televisions is 395, followed by radio 450 and newspaper 475. And then the total of the respondent is 1,320. So we call that the total row as well as column, we call as absolute frequently. And the question is, if you have the table like this, you can think about joint relative frequency, marginal relative frequency, conditional relative frequency. So meaning that if we have the informations like this, and then you can talk about how the joint relative frequency, marginal relative frequency, and conditional relative frequency. And we will talk then in the next slide. Okay, let's first talk about a joint relative frequency. A joint relative frequency gives the percent of or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. So look at the table, yeah, the table, contingency table above. For example, for combination between radio and male, meaning that what is the percentage of respondents who get information from radio and are male. So look at the combination, the first row and then the second column. So you have 175. So meaning that how many percent of 175 of 1,320? So you can calculate 175 divided by 1,320, and then you will get 13.3%. So we call this is joint relative frequency. Okay, another example, for example, what is the percentage of respondents who get information from television and are female? So look at this. In the contingency table, there are 115. So meaning that you can calculate 115 divided by 1,320. So you have 8.7%. So we call also a joint relative frequency. So as a summary, a joint relative frequency is percentage between the number of frequency every cell in certain cell, specific cell, divided by total of respondent, right? Okay. Okay, now it's still with the same contingency table, but we are talking about a marginal relative frequency. A marginal relative frequency gives the percents or proportions of individual that have a specific value for one categorical variable, row or column. So look at the tables above. For example, the respondents are male, a total at 760, while female is 560. So the question, for example, what is the percentage of male respondent? Of course, it will very easy to calculate. From 1,320, so the percentage of female is 760 divided by 1,320, right? So you will have 57.6%. Another example, what is the percentage of respondents who get information from television media? So you can look at here that the total of respondents through television media is 395. Of course, the percentage you can calculate 395 divided by 1,320, and then you will have 29.9%. So you can also calculate for another marginal relative frequency. Okay, do you understand? Okay, great. So if you have calculated all joint relative frequency and marginal frequency distribution, okay, and then you can make a table like this. Please look at the table above. This is put percentage of every cell, and then you can put also the percentage of the marginal, so you can see very easy to understand about what the meaning of percentage here. So you can also describe the table in form of the graph. For example, if you want to describe about male and female in the right side, yeah, so that means that the number of the male is more than female, and then you can also describe about the marginal based on the column information media. So you can look at here the table, the graph, I mean TV, radio and newspaper. You can see the percentage of the newspaper is the biggest compared with television and radio. Okay, so if you want to describe about the joint relative frequency, you can also make a description through the graphic like this, yeah. In every category, for example, in television, for example, through the television media, and then you can compare between male and female. For example, with television, male is more than female, but through radio, you can see here that female is more than male. But through newspaper, male is more than female. So this is describing of the joint relative frequency through the graphic. So marginal and joint relative frequencies cannot indicate or answer the question whether there is a relationship between two variables of information media and gender. This is just description. But how the relationship? Isn't there a relationship or not? This is just indication, yeah. But we cannot conclude about there is or not association between information media and gender. Okay. Okay. We are still in example 1, yeah, between information media versus gender. So we have still the same example, and then now we are talking about what a conditional relative frequency. A conditional relative frequency gives the percents or proportions of individuals that have a specific value for one categorical variable among individuals who share the same value of another categorical variable, meaning the condition. Yeah, this is more difficult to understand compared with what joint and marginal frequency. Okay, look at here. Yeah, so a little bit slowly. Yeah, so the question is, what percentage of newspaper information media are read by female respondent? This is the question, for example. Yeah, so look at this one. Yeah, you have the question is percentage of newspaper information media are read by female. So look at what is the media. The media is newspaper. How many total respondent read newspaper? The total is 475. So from 475 respondents, how many read by female respondents? This is 170. So the answer is, for the question is, percentage of the newspaper information media are read by female respondent is 170 divided by 475. This is 35.8%. Okay, clear? Okay, let's slowly to think, and then I will slowly to explain about this conditional relative frequency understanding. So another example is, if any question like this, what percentage of newspaper information media are read by male respondent? Actually, it can be calculated easier because read by female respondent is 35.8%. Automatically, read by male respondent is 100% minus 35.8%. This is equal to 64.2%. But from calculation side, for example, you can look at here, from 475 respondents, there are 305 respondents are male. So the percentage is 305 divided by 475. So you can get 64.2%. Therefore, the total between two items is 100%. So I hope that it will clear for you to understand about what a conditional relative frequency. And then you can also calculate for another issue. Yeah. Okay, so look at this table. Yeah, you have two tables. There are two conditional relative frequency distribution. The first one is about conditional media informations. The second table is about conditional gender. So look at here by column. Look at by column first. Yeah, because this is conditional media information. By televisions, the total is 100%. Radio, 100%. Newspaper is 100%. How you interpret this one? For example, for the first column, yeah. From the total respondents who watch televisions or who get the information from televisions, 70.9% is male and 29.1% is female. But through the radio, you can see here, from 100% of respondents, 38.9% is male, and 61.1% is female. Okay, clear, right? With newspaper, from 100% respondent, 64.2% is male, and then 35.8% is female. But in the other side, look at the next table, conditional gender. You look at the row, yeah, male and female. So we can interpret like this. From 100% of male, 36.8% get information from television, 23.0% from radio, and 40.1% from newspaper. While respondents female, from 100% of female, 20.5% get information from television, 49.1% from radio, and 30.4% from newspaper. So it is clear, I think, yeah. So to describe about the conditional relative frequency distribution, you can also make a graphic like in the right side, yeah. For example, through the conditional media informations, by televisions, you have two graph, and then radio, two graph, male and female, and then newspaper, you have also two graph, male and female. So you can compare between male and female for every newspaper media. In the other side, you can also make a graphic, for example, conditional gender. Yeah, male, you have three graphs, and then female, you have also three. So you can compare, yeah, between the block of graphs between conditional as you want to explain. Okay. So to answer about the questions, how to identify the relationship between two categorical variables, there is explanation like this. For example, you make a graph like this through the media, and then in each media, and then you have a graphs with the color blue and brown, yeah. In television, for example, you see here that male, the percentage of male is bigger than female, while with radio, male is smaller, yeah, than female, but with surat kabar or newspaper, male is bigger than female. So what we can say here with this graph, yeah, we can only say like this: there is an association or indication association between two variables if knowing the value of one variable help us predict the value of the other. Yeah. For example, information media can predict the relationship or can predict the relative frequency distribution of sex or gender. So from the picture, it is clear that the relative frequency distribution of the sex is different for each information media. So that means that there is indication that there is association between two variables. But if you have the graph like another graph in the bottom, for example, through the three media, you can look at here, percentage of male and females almost the same. If any case like this, for example, this is just example, this is from different data, yeah, not from the data that we just talked earlier. So if we have graphic like this, so we can say like this: if knowing the value of one variable does not help us predict the value of the other, then there is no association between the variables. So you can look at here, the bottom graph, information media cannot predict the relative frequency distribution of sex or gender, in the sense that the relative frequency distribution of gender does not depend on the type of media. So, I hope it's clear for you what the meaning of the association between two categorical variables. But remember, we are just talking about association. But you have to remember that association does not necessarily imply causality case. This is just association between variable A, for example, and B. It doesn't mean that B imply causation of B, not causal, not as a reasons of the B fluctuations, This is just association between two categorical variables. Be careful about this, Okay, after we are talking about relationship between two categorical variables, now we are talking about the relationship between two variables in which one variable is categorical and another one variable is numeric. So to see the relationship between two variables in which one categorical variable and one numeric variable, now we can just understand about the statement like this. When bivariate data is generated from one categorical variable and one numerical variable, the values presented are viewed as a separated example. And each dataset is identified by a category or level of categorical variables. This is the second understanding, And then the third is each of these data sets is described using summary statistic, and the results are displayed for comparison between categorical or level of categorical variables. So we have to explain again about the descriptive statistic that we already discussed in earlier meeting. The fourth statistic commonly used for comparison are measure of center and spread with the 5-digit summary. Remember, minimum, maximum, mean or average, median, and mode. You can also use the graph for comparison, for example, to the box plot or stem and leaf plot, for example. So this is the example for the case relationship between one categorical variable and one numeric variable. For example, we have 10 random samples of household from each of the 6 different sub-districts in Bogor are taken, and their electricity bills are recorded in June 2021. So as I explained before, we have 1, 2, 3, 4, 5, and 6 sub-districts, kecamatan, and then the number on the data under every column, this is electricity bills. You have 10 data in every sub-district. So how we can describe about the relationship between sub-district and electricity bills? So I will describe about this in the next slides. So the easiest way or easiest method that you can use, because you have also already learned about this, you can compare the set of the data with the box plot, with the different box plot. Comparison between box plots. For example, this is the box plot from 6 sub-districts in Bogor. So from this box plot, you can describe, for example, which sub-districts in which the respondents has smallest expenditure for electricity. So you can hear that in Bogor Timur or East Bogor. So the biggest median, for example, in this case, in Bogor Barat, for example, compared with the other. But from the distribution, you can also look at here, for example, although Bogor Barat, for example, West Bogor, on average, it could be the biggest, but there are also some samples or some households as the smallest expenditure. So through this box plot description or box plot figures like this, you can explain here that there are difference between expenditure between the people or household in 6 this sub-district or 6 kecamatan in Bogor. Okay. So now we are talking about the third case, a relationship between 2 numerical variables. Analysis of a relationship between 2 numerical variables. So there are some method or some manners to describe about relationship between 2 numerical variables. The first one, you can use the line chart or scatter plot, for example. And then the second one, you can measure of the strength of the relationship between the 2 numerical variables, and then we call it the correlation. Not association, but correlations. But some of associations measurement, you can use the Spearman rank correlations, and you can also use Pearson correlation or product movement correlation. In many times, we just call correlations. This meaning that the Pearson correlations. But if we use the Spearman rank correlation, normally we call it Spearman rank correlation. But if we just call correlation normally, what they mean is the Pearson correlation. So as I mentioned before, if you have 2 numerical variables, you can use the scatter diagrams. Scatter diagrams or scatter plots are used for graphic sparse observation taken from 2 numerical variables. I think we have already discussed in earlier meeting about the scatter plot. So on the scatter diagram, one variable is measured on the vertical axis and the other variable is measured on the horizontal axis, meaning that you can choose which variable it will be placed as a horizontal axis and then which variable that will be placed as a vertical variables or vertical axis. Okay. So for example, we have 2 numerical variables. In this table, you can look at here. The first column is volume per day. The second column is cost per day. If I'm not wrong, this is the data that we have already discussed earlier. The first column, volume per day, is the number of items sold. The second column is expenditure for advertisement, right? Do you remember? So, for example, if the expenditure 125 and then the item sold is 223, for example. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 data, pairs data. So to know is there any relationship between the 2 variables, you can make a scatter plot, and then in which you put here volume per day as a x-axis, and then the cost per day you put here as a column axis. So you can look at here, yeah. So this is the scatter plot between two variables. So this slide is just demonstrate you how if you use the Excel to make a scatter plot diagrams. Yeah, this is easier. Step by step you can see here. For example, the step 1, select the chart wizard, and then the second select is X and Y options, and then after that you can click X and Y scatter plot. So in addition to use the scatter plot to show the relationship between two numerical variables, now I want to introduce you the rank correlations. The Pearson correlations coefficient, and then normally we call R, is a measure of their linear association between two variables for which interval or ratio data are available. Remember, with the scale of variables, interval or ratio, this is numerical variables. So now we talk first about the Spearman rank correlation coefficient, and then normally we call R as Spearman, the name of someone who developed this method. Yeah, Spearman rank correlation coefficient is a measure of the association between two variables when only ordinal data are available. Yeah, so the value of RS can range from -1 to +1, where the value near 1, positive 1, indicate a strong positive association between the rankings, and the value near -1 indicate a strong negative association between the rankings. So the both indicate the strong association. The first one 10 to minus, this is negative association. The other is +1, this is the positive association. So this is the mathematical formula to calculate Spearman rank coefficient, correlation coefficient. So RS equal to 1 minus 6 sigma di quadrat square divided by n multiply n square minus 1. N is number of items being ranked, that means number of samples, number of data being ranked. Xi is rank of the I with respect to one variable. Yi is rank of item I with respect to a second variables. Di is difference between Xi and Yi. Yeah. So, for example, we have the data like this. Honor Investor provides a portfolio management service for its clients. Two Connors analysts rated 10 investment from the high 6 to low 1. Yeah. So, use rank correlation with the alpha equal to 0.10. Yeah, to comment on the arrangement of the two analysts rating. So look at this one. We have the investment A, B, C until G, and then based on the analyst 1, the first analyst, he ranked like this, the first row. Yeah, but from analysis 2 or second analyst, he ranks another. Yeah, with the same data, but the two analysts have the different rank from the G investment. So you can look at the column rank of analyst 1 and rank of analysis 2, and then you can make a differ DUI. Yeah. Differ between rank of the analyst 1 and 2. For example, investment A, and then the rank 1, the both analysts give the first rank, so therefore the difference is 0. The second for investment B, for example, the analyst 1 minus analyst 2, there is one difference. That means minus 1. 4 minus 5 is minus 1. And then until the investment G, the rank 10 and the rank 8, 10 minus 8, the difference is 2. So that the square of differ between analyst 1 and analyst 2, you can look at the last column here. 0 square is 0, minus square is 1, minus 1 square is 1, 3 square is 9, and so on. So the total of the square of differ is 92. So the Spearman rank correlation you can calculate with this formula: 1 minus 6 sigma di square divided by n, then n square minus 1. So you have here, you get here 0.4424. So the last one, we want to talk about coefficient of Pearson correlations. What is the Pearson correlation? Yeah, measures the relative strength of the linear relationship between two variables. Please remember, linear relationship. This is not non-linear. So how to calculate that? If our data is population, so the Pearson correlation rho equal to covariance x and y divided by standard deviation of x and standard deviation of y. This is formula if your data is population. But normally we don't have the population data, so that if we have the sample data, so we predict the rho with R. So the formula of the R equal to covariance x and y, and then divided with standard of deviation x and standard of deviation y. So this is for samples data. So what about the feature of coefficient correlation of Pearson? Yeah, Pearson coefficient correlation R. Yeah? The first one is the unit is free. That means there is no unit of the correlation. And then the range of correlation as a Spearman is between -1 and 1. The minimum is -1, the maximum is 1. Yeah, as well as Spearman correlation. The closer to -1, this is the strongest in the negative linear relationship. The closer to +1, this is the strongest, the positive linear relationship. If the closer to 0, this is the weakest any positive relative linear relationship. Again, if closer to 0, the weaker any positive linear relationship. It could be there is a correlation, but not linear. It could be, but it depends on the scatter plot between x and y. So let's look at the values of the scatter plot between x and y. For example, the first graph in the link side, yeah, at above, the plot between x and y is real straight in the straight line. Yeah. If like this your data, so this is the correlation, Spearman correlation is equal to -1. But if the scatter plot between x and y is like the middle graph, for example, you can look at that. Yeah. So the correlations, because this tend to negative, the correlation is minus. So it's, for example, around -0.6. So, but if the plot like the third graph, for example, the scatter plot, so the correlation between x and y is around to 0. In the same case, if the correlation between scatter plot between x and y, like the left side here in the bottom, yeah, this real the plot between x and y, the data real fit in the one line, so the correlation is +1. Yeah, The second graph is around 0.3, and the last graph is around 0. So this slide just demonstrates you how to use the Excel to calculate the coefficient correlations. I think this is easier, and then you can practice. Yeah, you can use the Excel to calculate the correlation of Pearson. So you can look at here this Excel's software. You put the first variables as the first column, A column, and then the second variable as B column. You have 10 data, and then after that you block, input data range and select appropriate option, and then after you block here, and then you click, and then you select here correlations here, and then after that Excel will give you output the correlation between column 1 and column 2. For example, here 0.73. So based on the scatter plot and then calculation of Pearson correlation 0.733, and then with the scatter plot like that, and then you can interpret like this. For example, there is a relatively strong positive linear relationship between test score and then test score 1, and then test score 2. So that means students who score high on the first test and then tend to have a score high on the second test. So this is the interpretation between the first variable and the second variable. Okay, that was the material for the 6 weeks meeting, and then I hope you can understand what I have already explained, and then the next week we will continue the material with regression analysis. Okay, thank you very much. Goodbye. See you next week.